Using rates of change, using related rates, let's find the rate of change in what's called an angle of elevation. So here's the situation. A balloon rises at a rate of 4 meters per second from a point on the ground 50 meters away from an observer. What's the rate of change in the angle of elevation of the balloon from the observer when the height of the balloon is 50 meters? Let's go ahead and underline everything we know. The balloon rises at a rate of 4 meters per second. There's a given rate of change. The ground distance between the balloon and the observer is 50 meters. We're trying to find the rate of change in the angle of elevation. As it is right now, the height of the balloon is 50 meters. So a picture's worth 1,000 words. Let's see if we can draw a picture. Here's my observer. Here's the balloon. Between the two, on the ground, is 50 meters. Does that distance change? As the balloon is going up and down, does the distance on the ground between the observer and the balloon change at all? No, so we're going to leave it the way it is. Leave that as 50. Does the vertical distance that the balloon is off the ground change? Yeah, so let's label that with a variable. I'm going to call that y, for example. That vertical distance, let's call y. I'll complete the right triangle by doing that. Right now, what's the height of the balloon? 50. All right. It's going to change, but right now it's 50 meters off the ground. We're trying to find the rate of change in the angle of elevation. The angle of elevation is how much this person on the ground has to look up to sight the balloon, to spot the balloon. So let's label that angle as theta. We're trying to find d theta dt, the rate of change in that angle of elevation. So d theta dt is, I don't know. See, I think I'm giving something else. What am I missing here so far? So how would I label that 4 meters per second? Using our notation that I built so far, what would 4 meters per second? dy dt. It's the rate of change in that length y, the height of the balloon off the ground, yes? So dy dt equals 4 meters per second. What we're trying to find is, as the balloon is going up, what's that rate of change and how far I have to tilt my head back to look up at the balloon, right? How far do I have to keep turning my head up? How fast am I doing that to look up at the balloon? So we need an equation between theta, y, and the 50-meter ground distance between the balloon and the observer. Since we're talking about angles in a right triangle, let's think back to good old SOHCAHTOA. Which trig ratio relates angle theta with the two sides I have labeled? So which one? Tangent. Tangent of theta equals opposite over adjacent. So tangent theta equals y over 50. There's the equation I'm going to have to differentiate. I want to find d theta dt. So let's do it. Tangent theta. What is the derivative of tangent? secant squared theta d theta dt. Let's do the same thing to the other half. I'm going to differentiate y over 50 with respect to time. But just so I don't have to use quotient rule, let's call that 1/50th y. What's the derivative of 1/50th times y? I'll bring down the 1/50th because it's just a constant. dy dt. Since I'm trying to solve for d theta dt, let's solve this equation for d theta dt to get it in terms of what I'm trying to solve for. So I need to divide both sides by secant squared. Divide both sides by secant squared, or call that 1 over secant squared. What's 1 over secant squared the same as? 1 over secant identity 4. You had it, Maddie? Cosine. The cos never go together. Secant and cosine are reciprocals. Cosecant and sine are reciprocals. So let's just call this cosine squared theta times 1/50th dy dt. I suppose you don't have to go ahead and get cosine squared on the other side. You could just plug in everything you need right here, but I think it's best to kind of maybe write it like this, so I can work with cosine and have my d theta dt kind of ready to go. My equation's already in terms of what I need to solve for. All right. Cosine squared theta. Look at the triangle again. I need to know what cosine of theta is. Think back to SOHCAHTOA. What is cosine? Okay, so I know what the adjacent side is. Is that just 50? But how long is the hypotenuse? What's this distance diagonally from the observer up to the balloon? I know that the side y is also 50 meters. How can I figure out what this missing side length is that I need to find my answer? Pythagorean's theorem. 50 squared plus 50 squared equals this side length squared. Right. Remember back from your work in advanced math. This is actually a special right triangle. If these two sides are the same, 50 and 50, the other side is that same side length times what radical? Do you remember? You wouldn't have to. You can always fall back to Pythagorean theorem, but we can save some time by just remembering that this is a special right triangle, the 45, 45, 90 triangle. If the two legs of the triangle are the same, the hypotenuse is the length of the leg times an extra root 2. Does that sound familiar? No, it's been a year since you had your trick, Mr. Alexander. So this would be 50 root 2 meters that you would find using Pythagorean's theorem anyway. Let's plug in everything I need. D theta dt equals cosine squared. What did we say cosine was a second ago? What ratio? What divided by what? Think SOHCAHTOA. Adjacent over hypotenuse. So adjacent 50 over hypotenuse 50 root 2. 50 divided by 50 square roots of 2 squared, because it's cosine squared, times 1/50th times dy dt, which is 4. Balloon's going up at 4 meters per second. So let's see, I could cancel this out. All that's left is just simplify this version, this expression here on the right. D theta dt equals 1 over root 2 squared times 1 over 50 times 4. Let's just call that 4 over 50. What would 1 divided by root 2 squared be? 1 divided by root 2 squared. 1 squared and root 2 squared. Yeah, I'm sorry.
Do you want the decimal or like?
It should be a pretty straightforward decimal. It should be point with one other number. Take 1 squared and root 2 squared. Square both top and bottom. 0.5. 1 squared is 1. The square root of 2 squared would just be 2. So this is actually just 1/2. Half of 4 over 50. That would be 2 over 50. Or 1/25. If you're talking about an angle measure, we're going to measure this angle in radians. Radians per second. (1/25th radian per second). I have to turn my head up at 1/25th radian per second. I don't know what a radian looks like. I might want to convert this to degrees. So 1/25th radians, in terms of degrees, I take it times 180 degrees over 1 pi radian. Let's convert this back into a degree measure. Otherwise, I don't know what my answer really is. 180 divided by 25 pi is about 2.29 degrees per second. Well, do you want to give it in terms of radians per second or degrees per second? There you go. My head is tilting up at approximately 2.29 degrees per second as this balloon rises